Science is a puzzle, and for decades, the periodic table had a glaring missing piece, element 43. In the 1860s, Dmitri Mendeleev organized the elements and boldly predicted that the gaps in his table would one day be filled. One such gap, below manganese, was dubbed Eka manganese. For years, scientists searched for this element, grinding rocks, dissolving minerals, but found nothing. The spot for element 43 remained empty, a ghost haunting chemistry. They could predict its properties, a metal heavier than manganese, with similar chemistry. Yet it was nowhere to be found in nature, puzzling scientists worldwide. Why would this element, nestled between common neighbors, be missing? The search became a global quest, pushing the limits of chemistry and physics. Mendeleev's table was powerful, but every blank was a challenge to its accuracy. Finding element 43 would confirm the periodic law and our understanding of matter. The hunt was on, filled with bold claims, dead ends, and the promise of a revolutionary discovery. The ghost in the periodic table was waiting to be found. The stage was set for one of science's greatest detective stories. In 1925, German chemists Walter and Ida Noddack with Otto Berg claimed they'd found element 43, mesurium, using X-ray spectroscopy. Their discovery of element 75, rhenium, was quickly confirmed, but mesurium was another story. No one else could replicate their results, and they never isolated a visible sample. The faint X-ray signals they reported were dismissed as errors, political tensions, and the controversial name added to the skepticism. Years later, when asked for their original data, the Noddacks said it was lost. With no reproducible evidence, the scientific world rejected their claim. The spot for element 43 was declared empty once more. The ghost remained, and the search continued. The controversy only deepened the mystery. The periodic table's puzzle piece was still missing. The breakthrough came not from mining, but from the lab. At Berkeley, Ernest Lawrence's cyclotron smashed atoms together, creating new possibilities. In 1936, Emilio Segre took a radioactive molybdenum foil from the cyclotron back to Italy, suspecting it might contain element 43. Teaming up with chemist Carlo Perrier, they used careful chemical analysis to hunt for the new element. They ruled out all known elements. The radioactivity had to come from something new. They had created, not found, element 43. In 1947, it was officially named Technetium, from the Greek for artificial. This was the first synthetic element, made by humans, not found in nature. The discovery filled the gap in the periodic table and proved Mendeleev's predictions right. It marked the dawn of synthetic elements. A discarded piece of metal had changed science forever. The ghost was finally real. Humanity had made what nature could not. Why was technetium so elusive? Because it's radioactive and has no stable isotopes. Its most stable form, technetium-98, has a half-life of just 4.2 million years, a blink in Earth's 4.6 billion-year history. Any technetium present at Earth's formation decayed away long ago. That's why Segre and Perrier had to make it. Nature on Earth couldn't keep it around. Today, only trace amounts exist naturally, produced by uranium decay, far too little to detect easily. Nearly all technetium we use is man-made. Its fleeting existence makes it a scientific curiosity and a window into nuclear physics. Technetium's presence in stars tells us about stellar life cycles, while its absence on Earth reveals our planet's ancient past. It's the element that wasn't there until we created it. Its story is a testament to human ingenuity. Ida Noddack's story didn't end with mesurium. In the 1930s, she challenged Enrico Fermi's claim of creating new elements by bombarding uranium. Noddack suggested something radical. Maybe the uranium nucleus split into smaller pieces. She was describing nuclear fission years before anyone else. Her idea was dismissed as absurd and her paper ignored. But in 1938, Otto Hahn and Fritz Strassmann found barium after bombarding uranium, confirming Noddack's insight. Lisa Meitner explained the results as nuclear fission, vindicating Noddack. Her story is a lesson. Revolutionary ideas can be overlooked if they come from outsiders. Being right isn't always enough in science. Ida Noddack's vision changed our understanding of the atom. Technetium's journey didn't end in the lab. Its isotope, technetium-99, revolutionized medicine. With a half-life of just 6 hours, it's perfect for medical imaging. Short-lived, safe, and effective. Injected into patients, it emits gamma rays that create detailed images of organs, then quickly decays away. Tens of millions of scans use it every year, helping diagnose heart disease, cancer, and more. Technetium 99Nin is attached to molecules that target specific tissues, revealing hidden problems without surgery. This process, scintigraphy, gives doctors a powerful window into the body. What began as a missing piece in the periodic table became a life-saving tool. The story of Technetium shows how curiosity-driven science can transform our world. The element Earth forgot is now one we can't live without.